Good day and welcome back to my channel. In the previous videos, we looked at how to find a derivative using first principles and short differentiation. In this video, we will discuss what does a derivative mean. Let's go through the definition. A derivative of a function is an equation for the gradient at any point in the function. What this means is that if we have an equation of the function and we find its derivative, that derivative will be able to allow us to work out the gradient at any point in that function. Now let's look at an example to illustrate my point. We have an equation y is equals to minus x squared plus 2x plus 3. This is obviously a parabola which I've sketched alongside. This is just a rough sketch. So, according to the definition of the derivative, if I find the derivative of this equation, it should give me an equation that allows me to calculate the gradient at any point in this function. Now let's go and compute the derivative. So y prime equals to minus 2x plus 2. This should be easy for you by now. So basically, the derivative is the same thing as the gradient. So we can say gradient equals to minus 2x plus 2. Now, we notice that there's a variable x, and this is obviously any point along the x-axis. So, if I substitute a point, say, x equals to 2, it should give me the gradient at this point. So let's do that. I have to just substitute the value of 2 into the equation to get my gradient. So gradient equals to minus 2 multiplied by 2 plus 2, which is obviously equals to minus 4 plus 2, which is equals to negative 2. This means that at the point x equals to 2, the gradient of the graph is minus 2. Likewise, we can do the same thing for any point, any x coordinate, and this will give us the gradient of the graph at that x coordinate. Now, this applies to any type of graph. Now, obviously, a straight line graph, we have a constant gradient. Now, let's prove that using the definition of the derivative. We have the graph y is equals to a half x plus 1, as I've roughly sketched alongside. Let's find the derivative of this equation. Y prime equals to a half, which is essentially the same thing as m equals to a half. That means that since the equation for the gradient is not dependent on x, it means that the gradient is constant right throughout every single x value. And we know that because it's a straight line graph. We also know that according to the equation y is equals to mx plus c, the coefficient of x is simply the gradient, which we can see here as a half. Now, let's go back to our parabola. We have the same parabola, y is equals to minus x squared plus 2x plus 3. Now, as we said, once we find the derivative, we can plug in any x value and it'll give us the gradient at that point in the graph. But what do we know about the gradient of the tangent at the turning point of a graph? We know that the turning point, also known as the stationary point, because the gradient at that point is 0, since it's a completely horizontal line. So, like how we substituted an x value to determine the gradient, surely we can substitute the gradient to determine the x value. This means that we can find the turning point of any function using the derivative. Let's do that. So the derivative of the above equation, like we've done before, is y is equals to minus 2x plus 2. Now we said that the derivative is the same thing as the gradient. And we said that the gradient of the turning point, or the gradient of the graph at the turning point, is 0. So if we substitute 0 for m, and if we solve for x, surely we get the x coordinate of the turning point. Now let's do that. Taking minus 2x to the other side, it becomes positive. And we're left with x equals to 1. This means that for the above graph, y is equals to minus x squared plus 2x plus 3, the x coordinate of the turning point is 1. And we can find the corresponding y coordinate by simply taking this x equals to 1 and substituting it into our original equation. And if we do this, we get a y coordinate of 4. So, as we see, we can use the concept of a derivative to determine the turning point of any function. So the turning point for the above function is 1 and 4. Now, this concept of finding a turning point of a function by finding its derivative comes in handy in the following two sections that we will do: cubic functions and application calculus. Now, just to recap, in this video, we covered that the derivative can be used to find the gradient at any point in a function. And it can also be used to find the turning point of a function. If you enjoyed this video, please give it a thumbs up and subscribe to our channel. Also, don't forget to follow us on Instagram at ace.academics.tuition.